In this lecture, we are going to look at how to calculate alpha and beta in code. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. To start, we're going to download our data. We'll need both the SPY dataset as well as a subset of the S&P 500 so we can compare one of these stocks to SPY. Next, we're going to import our usual libraries, NumPy, Pandas, and Matplotlib. Next, we're going to load in the SPY dataset as we normally do, using pd.readcsv. Next, we're going to calculate the return for SPY using the %change function. Note that I'm giving this column the name SPY instead of something generic like return. This is because I'm going to join this with another data frame later, so I want it to have a more informative name. Next, I'm going to load in the S&P 500 stocks using pd.readcsv. I'm going to call this data frame index since it contains stocks from the S&P 500 index. Next, I'm going to extract the Apple stocks by choosing only the rows where name equals AAPL. Next, I'm going to calculate the returns for the Apple stock by using the %change function again. Notice again how I'm giving this a unique name by calling it AAPL instead of something generic like return. Next, I'm going to create a new data frame called joined. This is going to equal the Apple data frame, filtering only the return column, joined with the SPY returns. Next, I call the head function to ensure that my new data frame is in the correct format. Next, I'm going to plot this data frame, which means it's just going to plot every column as a time series as usual. Note that since returns are very noisy, it will be easier to see a clear pattern if we select a small subset of the data. So I've used iloc to select the rows from 100 to 150. Obviously, this is completely arbitrary. You can choose whatever rows you feel like. Now notice from this plot how closely Apple's returns track the market returns. In fact, they also appear to be on the same scale as well. So when SPY goes down by this much, Apple goes down about the same amount. And we see the same pattern here. So you don't see Apple going much higher than SPY or much lower than SPY. And based on this, try to think about what beta might be. Will it have a large value or a small value? Will it be positive or negative? Next, I'm going to create a scatter plot of Apple versus SPY. Notice that from this plot, the correlation doesn't appear to be as strong as it looks in the above plot. It does look like there is a clear upward trend. Next, we're going to work on creating our dataset so that we can do some machine learning. Although we don't need to convert our data into NumPy arrays, we're going to do it anyway since I think it's easier to understand that machine learning works on numbers and not data frames per se. So the first thing I'm going to do is drop all the NAs. We don't need those when we're doing machine learning. And next, we're going to filter out SPY and AAPL. So by passing in a list of column names, even though each list only contains a single symbol, we get back a data frame which is a two-dimensional object. Then we call the toNumPy function to convert the data into NumPy arrays. We'll assign these to the variables x and y. Next, when we check the shape of x and y, we see that they are in fact n by 1 two-dimensional arrays. And remember, that's what we need for machine learning. Note that it's not necessary for y to be two-dimensional, but there's no harm in making it two-dimensional. Next, we demonstrate that if we do a scatter plot of x and y, we get the same plot as before. So nothing has changed, the data is just in a different format. Next, we import the linear regression class from scikit-learn. Then we go through the usual steps of instantiating a model and calling the fit function on the data. By the way, if I haven't reminded you yet that I teach all about how to use scikit-learn in my free course, and you don't know how to use it, then you might want to go and check that out if you find this confusing. As always, since I teach this stuff for free, I don't anticipate any problems with learning these basics. In the next block, we're going to draw the scatter plot again, along with the line of best fit. In order to draw the line, I'm going to first create an input array xPredict of equally spaced points. Note that because this is a line, we really only need 2 points, one at the beginning and one at the end. I just chose 5 points arbitrarily. As usual, we go from the min-x to the max-x so that the line spans across the entire dataset. Also, note that I reshaped the linspace output to n by 1 so that this can be passed into the scikit-learn model. Next, I call model.predict, and this gives me yPredict. And next, I draw the scatter plot again, along with the line plot from the data I just created. So what do we see? Well, it's pretty much what we expect. There's our data and there's our line of best fit. Next, we're going to retrieve alpha and beta from our fitted model. You might want to check the scikit-learn documentation so you can learn about the model's attributes. Specifically, the slope is located in the attribute coef, and the intercept is located at the attribute intercept. As we discussed in the theory lecture, in finance we call these beta and alpha. Alright, so what do we see? Well, we see that alpha is very slightly positive. This is about 4.6 basis points, and beta is approximately 1. That makes sense because in our plot earlier, we saw that Apple's returns lined up very closely with SPY. Next, I'm going to show you how to draw the exact same plot we had previously with the line of best fit. But this time, we're going to calculate the line manually using alpha and beta. This will prove to you that the equation I described to you before does in fact correspond to the line. That is, beta times the market return plus alpha. Alright, so we see that our new plot looks exactly the same as our old plot, thus confirming that our equation is correct. Now you might think, perhaps it's better to invest in Apple than it is to invest in the market, due to its positive alpha. However, another important aspect of finance is risk or volatility. As mentioned previously, one common way to measure this is with the standard deviation. If we look at the standard deviation of our data frame, we see that the volatility for Apple is about twice that of the market. So while Apple did have better returns, it also had higher volatility. This is a common pattern in finance where, generally speaking, if you want higher reward, you have to be willing to take on more risk.